All right, today we're diving into some research that could fundamentally change how we invent new technology. We're talking about the AI Telco Engineer. So think about this for a second. We're all getting pretty used to asking AI to do creative stuff, right? Write a poem, summarize an email, whatever. But what if we aimed way higher? What if we could give an AI a really complex engineering problem and just ask it to invent a brand new solution, all on its own? And that's the core idea we're exploring. We're talking about making a huge leap from an AI that just responds to our commands to one that actually and independently works to achieve a goal. It's a massive shift from a reactive tool to a proactive, tireless problem solver. So let's meet the star of this explainer, the framework the researchers actually built to do this. They call it the AI Telco Engineer. The key concept making this all possible is called agentic AI, and this is a really crucial distinction. This is not just a language model sitting in a chat box. An agentic AI can take initiative. It can create a plan, execute that plan, and use tools to get to a final objective. It's an active player in the game. The framework has this pretty brilliant two-tier architecture. You've got an orchestrator LLM. Think of it like a lead scientist, the one coming up with the big ideas and strategies. Then you have a whole team of agent LLMs, kind of like a bunch of dedicated researchers who take those ideas and try to implement and test them out, all at the same time. It's basically a nonstop innovation engine. And this is how that whole workflow plays out. It's this incredibly powerful loop. The orchestrator kicks things off with a few different ideas. Then, multiple agents get assigned to each idea, and they start exploring different ways to make it work. They're actually writing Python code in these little digital sandboxes and testing it. And the evaluation tool, that's the judge, it's totally locked down so the AI can't cheat by changing the test. All the results, the good and the bad, get sent back to the orchestrator, which learns from it and comes up with even smarter ideas for the next round. Okay, so a cool framework is one thing, but how did this AI engineer actually do in the real world? Well, the researchers gave it 3 genuinely difficult challenges straight from the world of wireless communications. The first task was basically like trying to decipher a radio signal in a super noisy environment without any hints, like navigating a maze without a map. The second task was similar, but this time, the AI got the map, or, in technical terms, the channel's statistical properties. And the third was a dynamic challenge, constantly trying to pick the perfect data speed to get the best performance without ever dropping the connection. I mean, these are tough problems that human engineers spend entire careers on. And for those of you curious about what was under the hood, the framework was run using 2 different models to see how they'd stack up: a closed weights model, GPT 5.4, and an open weights model called GPT OSS 120B. So the big question, how did it do? Well, this is where we get to the really surprising wins and also some very important limitations. So get this, on that first task, the one navigating without a map, the standard human-designed method is called least squares. The algorithms that the AI came up with didn't just match this baseline. Nope, they significantly outperformed it. It came up with more complex and, well, just plain better solutions entirely on its own. Now for the second task, where the AI was given the map, the story is completely different but just as fascinating. See, for this problem, human engineers have already designed an incredibly powerful solution called the LMSE filter. The AI, without being told a thing about it, independently rediscovered and implemented its own versions of this exact same optimal method. And this highlights a really key insight from the paper itself. The researchers point out that when a really strong, well-known solution already exists, the AI is brilliant at finding it, but it tends to lock onto that solution instead of discovering something totally different. It's an incredible problem solver, but maybe not a truly radical inventor. At least not yet. But hold on, remember that third task? The one about choosing the perfect data speed or link adaptation? This is a messy, dynamic, real-world problem, and this is where the AI really, really shined. The algorithm generated by GPT 5.4 achieved a 3.43% gain in what we call spectral efficiency over the finely tuned industry standard. Now I know, 3.43% might not sound like a huge number, but let me tell you, in the world of telecommunications, an improvement like that is a massive deal. It translates directly to faster, more reliable connections for all of us. And this chart just puts that win into perspective. On the left, you see the performance of the ALA baseline. That's the current highly tuned method they use in the industry. And on the right, you can see the AI engineer's solution clearly pulling ahead. It just found a smarter way to manage the connection. So what does all this mean? Are we on the cusp of a completely new age of automated scientific discovery? Maybe the most powerful thing about this whole approach is this. Unlike a lot of deep learning systems that kind of act like a black box, the AI engineer's solutions are not a mystery. It spits out clean, human-readable Python code, and that means scientists can actually look at it, understand why it works, trust it, and even build on top of it. So, let's just pull it all together. What are the key takeaways here? Well, we've seen that agentic AI is capable of autonomously designing really sophisticated technology. We've seen its results are competitive with, and in some cases, can even beat human-designed standards. And critically, these solutions are transparent and explainable. The goal here isn't about replacing scientists, but about giving them an incredibly powerful new partner for discovery. And that leaves us with a final thought. The AI Telco Engineer proved it can tackle major challenges in wireless tech. It's ready for its next assignment. So the real question is, what problem should we ask it to solve next?